Zojila Tunnel, India's Himalayan lifeline, engineering the tunnel that rewrites geography. The Zojila Tunnel represents one of the most ambitious Himalayan engineering efforts in India's modern history, a project conceived not merely as a transportation upgrade but as a strategic rewriting of geography itself. For decades, the Zojila Pass, perched at roughly 11,575 feet, has been the fragile hinge connecting Kashmir to Ladakh, a corridor that winter storms routinely sealed for up to 6 months each year. The tunnel is designed to break this cycle of isolation by carving a permanent, all-weather artery through some of the most unforgiving terrain on the subcontinent. At its core, the Zojila Tunnel is a single-tube, bidirectional passage stretching approximately 13.1 kilometers, making it one of the longest highway tunnels in Asia at this altitude. Its cross-section is engineered to accommodate 2 lanes of traffic with a full safety shoulder, supported by a ventilation and evacuation architecture that mirrors European alpine standards. The tunnel's diameter, roughly 12 to 14 meters, allows heavy military logistics convoys, fuel tankers, and civilian traffic to move simultaneously without the bottlenecks that plague the current pass road. The design speed of 80 km per hour transforms what was once a treacherous 3-hour climb into a seamless 15-minute transit. The geology of the Zojila axis demanded a construction philosophy that blends flexibility with brute capability. The project employs the new Austrian tunneling method, NATM, a technique that allows engineers to adapt support structures in real time as they encounter shifting rock strata, shear zones, and water ingress. Excavation teams work from multiple faces, supported by a network of adits and access points that shorten the tunneling timeline. The tunnel lining uses a composite of shotcrete, rock bolts, lattice girders, and a final waterproof concrete layer designed to withstand extreme freeze-thaw cycles. At this altitude, temperatures can plunge below -20 degrees Celsius, and the engineering envelope anticipates ice formation, seepage, and pressure variations with a resilience normally reserved for deep mountain rail tunnels. The ventilation system is a defining feature of the Zojila design. A longitudinal ventilation architecture, powered by high-capacity jet fans, ensures continuous air renewal even during peak traffic or emergency scenarios. The tunnel integrates emergency lay-bys every 750 meters, fire-rated cross-passages, and a fully redundant power supply with automatic switchover. Intelligent traffic management, CCTV coverage, and incident response stations create a controlled environment that contrasts sharply with the unpredictability of the open pass. Yet the Zojila Tunnel cannot be understood in isolation. It forms a twin-pillar system with the Zimor Tunnel, a 6.5 km structure near Sonamarg that stabilizes the lower segment of the Srinagar-Leh highway. Zimor is engineered as a horseshoe-shaped, 2-lane tunnel with a parallel escape tunnel, designed to keep the Sonamarg Valley accessible year-round. Together, Zimor and Zojila convert what was once a seasonal route into a continuous, all-weather corridor stretching from Srinagar to Dras, Kargil, and onward to Leh. The strategic implications are profound. Ladakh's connectivity has long been vulnerable to weather-induced isolation, complicating civilian life and military logistics alike. The Zojila Tunnel reduces dependence on the high-altitude Zojila Pass and ensures uninterrupted movement of supplies to forward areas near the line of actual control. In winter, when convoys previously halted for months, the tunnel will allow the Indian Army to maintain a steady logistical rhythm, enhancing readiness and reducing the need for costly airlift operations. Economically, the tunnel promises to reshape the region's rhythms. Tourism in Sonamarg and Ladakh, once constrained by seasonal closures, will gain a year-round horizon. Freight movement becomes predictable, lowering costs and enabling industries in Kargil and Leh to integrate more deeply with markets in Kashmir and the rest of India. The project also anchors a broader vision of Himalayan infrastructure modernization, complementing bridges, avalanche galleries, and high-altitude road upgrades across the northern frontier. Constructing such a tunnel in the Himalayas is not merely a feat of engineering but a negotiation with geology, climate, and altitude. Workers operate in oxygen-thin air, machinery must be winterized, and logistics chains stretch across narrow mountain roads. Yet the project has advanced with a pace that reflects both technological capability and national priority. The tunnel's portals, ventilation caverns, and internal lining have taken shape through a combination of precision blasting, mechanized excavation, and continuous monitoring using geotechnical sensors embedded throughout the structure. When completed, the Zojila Tunnel will stand as a symbol of India's determination to overcome natural barriers through engineering excellence. It transforms a once perilous mountain crossing into a stable, predictable, and strategically vital corridor. More than a tunnel, it is a statement of permanence, a declaration that the Himalayas, while formidable, need not dictate the terms of connectivity or national security.